Now the indefinite integral. What is the difference? The reason the first one was called the definite integral is because we get a definite answer. The indefinite integral, we do not get a definite answer. Essentially the same, but you'll notice there are no limits on it. That's where it goes back to the primitive function idea. Was, well, in that case, I'll have plus a constant. There might be a constant there. You don't have the constant in the definite integral because when you subtract, the constants will cancel out. Here we need it. And that's really the only difference between the definite integral and the indefinite integral. There is this theorem known as the useful theorem because it's useful. Right? If you have a linear function to the power of n, you can still use that idea of add 1 to the power over the power. However, you also need to divide by whatever the coefficient of x is. So a in this case. But remember, must be a linear function for that idea to work. A couple of quick examples. If I've got that, what this does, it means I don't have to expand the whole thing out. I can just go, well, like, hang on, I'll just add 1 to the power over the power. Oh, but I also need to divide by -5, the coefficient of x. So I get -1/20 2 minus 5x to the power of 4 plus, in this case, a constant. This one, it's certainly useful for this one because how would you expand that out anyway? 3x plus 1 to the power of -2. How do you expand that out? Add 1 to the power over the power, but also dividing by 3 the coefficient of x. There's our answer. I mean, it's up to you whether you want to expand the denominator out, I suppose, but that's a good answer. Certainly useful, something like that. How would you expand out 2x plus 1 to the power of a half? Add 1 to the power over the power, but also dividing by 2 in this case, the coefficient of x. 1/3 2x plus 1 to the power of 3 on 2, plus of course a constant. That would be the answer mere mortals would write down, but of course us super mathematicians, we would rewrite it as 1/3 2x plus 1 root 2x plus 1. Far more impressive. People go, oh wow, look at that answer. That looks terrific. This person really knows what they're doing. All right.